Elon Musk's SpaceX company has completed another test flight with its massive reusable rocket, Starship. It successfully lifted off from a company launch site known as Starbase in Texas. Musk hopes the rocket, the largest, most powerful ever built, will one day take humans to Mars. The U.S. space agency NASA plans to use it for a crewed lunar mission scheduled for 2027. But after a series of tests ending in spectacular explosions, there are concerns that this could be delayed. This time, Starship's 11th test flight, the rocket deployed several mock Starlink satellites and performed test maneuvers before splashing down in the Indian Ocean after its hour-long flight. Now, for more, let's cross over to Keith Cowing, editor of the blog NASAWatch.com, and he joins me from Washington, D.C. Welcome, Keith. Good to have you with us. What insights have we learned from or gained from this test flight?
Well, Tommy, one of the simplest things that comes with rocket science is watching the video. And if things aren't shaking, if you don't see flashes and so forth, if it's just steady, you get a good feeling right off the bat, which is what we got from this mission. And the attempt was to launch the rocket first stage, do some things with the engines and have it land in the water. And they were practicing the landing, and he did that perfectly. And then they did some things in space where, as you mentioned, they deployed these mock Starlink satellites. And on the way in, and I can use a little model here, it's a space shuttle, but on the way in, they sort of played with the way that it comes through the atmosphere, and then it landed in the water, and then it blew up. But the blew up part is not part of the test. So what did we learn? Well, we learned that the design works, and if you tweak a few things, that you can get it to be more reliable. That's why you see these tests. They fly them. If something goes wrong, you learn from that mistake, you apply it to the next flight. And if you expect to make mistakes and be able to fix them, you can sometimes get a rocket that works the way you want to faster than the traditional way, which is the way NASA does things.
Isn't this a risky method, though, of development?
Yes, and it's all the whole idea here is, how do you deal with risk? Do you run away from it and try and just plan and plan and plan and plan and make sure that the rocket will never have a problem and take years and spend all this money on it? Or get as close as you can, be confident, launch it, and see how it performs, expecting that you're going to lose things. There are two different approaches to achieve the same thing. What they've got now with Starship is something that's vastly more capable than anybody anywhere has ever built. They can launch, they build these things like corn silos. They can improve them like they improve cars. And when this thing is operational, it'll fly like an airline. NASA has nothing like that. So you balance the risk against the benefit, and then you have a lot of money to work with.
Speaking of money, there is this multi-billion-dollar contract to develop Starship as NASA's lunar lander, but we've seen delays as well. Artemis 3 potentially years late. So is Elon Musk's timeline slipping beyond what NASA can afford?
Well, there's a joke of something they call Elon time, where he'll say, I'll do something by this date, and he misses the date, but he always ends up doing it. The problem now is that we have, here in America, we've committed to launch the Artemis mission to land on the moon on a certain date, and we are in a self-appointed competition with China, and they're moving ahead at a pace, and everything's working well with their program. And when they picked SpaceX, one of the things that went with that is that you launch the rocket that's going to land on the moon, but you have to refuel it a bunch of times in Earth orbit before you leave. So you have to launch more Starships that dock with it and fuel it up. And you'll need a dozen or so of those flights. So this is sort of like expecting every flight between Berlin and London on a rainy day to make it, and do it flight after flight, have it happen perfectly. And if any one of them misses, you have a problem. That's become problematic for NASA because this all relies on how reliable the rocket is. Today's flight should give them a little bit of a feel better mood, but they've got to be able to do this. Well, they've got to be able to do it several times a day.
Keith Cowing, as always, good to get your insights. As Keith Cowing, editor of the blog NASAWatch.com. Thank you very much.